For the panel, we're going to really focus on content, especially the idea of what is the impact of AI on hardware products. I think we got a good idea of some of the exact applications and things at SRI, and this is really going to be a cross-section perspective of what's happening in the space, and then as a hardware company, what are the things you can do to adapt as part of that. Alistair's founding partner at Creative Ventures. Maybe put your hand up there so people know who you are. They are a seed stage fund focused on high-tech hardware, so he's got a lot of hardware experience. Multiple AI and hardware robotic investments. Went to Brown University undergrad and UC Berkeley MBA, so we're very pleased to have Alistair moderate, and I think he'll spice it up. He likes to keep things exciting on the stage. And then I'll just go in order of the way it is here. So let's start with Luke. Maybe put your hand up there. He is general manager of the Tech Code Accelerator. Very pleased to have him. And then next to him is Mark Jacobstein. He's chief user engagement officer at Garden Health. Put your hand. Thank you. Welcome. And next is Radhika Dirks. Very pleased to have her. She's been a startup entrepreneur in the AI space and currently is a partner at XLabs. And then finally, we have Greg Reichow. He was former VP of manufacturing at Tesla Motors and now currently an investor at Eclipse VC. So welcome, everybody, and I'm going to pass it off to Alistair.
Thanks very much, Mike. I think I'd like to start this off by, we see a lot of news about AI, robotics, all that sort of stuff, all the things that everyone is doing. I'd really like to start by asking you, and Radhika, if you'd like to start, I'd be interested in knowing what you think are the underexplored opportunities, the opportunities other people are not seeing.
Oh yeah, this is one of my favorite questions. So the landscape in AI over the past few years has been morphing. And what has happened because of that, the little wave that started about 5 years ago has become a bubble. And so you see a lot of hype. But underneath the hype, there is insane amount of underexplored opportunities. So for example, one of the hypes, everybody keeps hearing about deep learning, which is essentially 80s algorithms applied to today's computers, the success made possible because computers have become faster, cheaper, better. But because of that, all the algorithms are focused on simulating or mimicking human-type intelligence. The underexplored opportunities are those that go beyond simulating human intelligence, meaning amplifying human intelligence. A great example, because I love to get into the specifics right away, a great example would be something we did at my previous company, Selden, where we ingested all of the world's data, and automatically we were able to predict with one system global crashes, so sort of socioeconomic disruptions, if you will, from labor strikes to jumps in commodities and currencies, things that no human is good at because we suck at assimilating complex information. So that would be a phenomenal underexplored opportunities, because out from that comes insurance applications, banking. Are we back? Yeah, banking applications and whatnot. So there's plenty in this space, and that's just one example. If we think beyond mimicking human intelligence and go into what is possible from a superhuman intelligence perspective.
And so I'm curious, Luke, what have you seen from your perspective as someone who's worked with a lot of the corporates? What are they clamoring for that isn't there?
Right. I think this is a very interesting way of asking the question. Usually we get asked what are the hot areas, right, within the AI. So we run the AI accelerator across many different applications, across different verticals. When startups systematically looking for opportunities, I think there are two areas of opportunity that are usually overexplored. One is the big market opportunity, right? For example, self-driving cars. One is the area that the AI is only a small enabler, therefore may not be the most important competency for the startup. So if we think reversely, what are the underexplored? And then there are two areas that I think, one is the market may not be that big, right? but still $1 billion market, but not hundreds of billions of dollar market. We have a portfolio company that does real estate application. Basically, they're using AI to predict and detect where the water pipes leak, right? This is very niche application. So for the second area, I think if it's only a small enabling factor for the application, one example is, you all know the iPhone 8 that just coming out, quite disappointing. One of the features we're looking for is the fingerprint sensor underneath or within the all screen, full screen. They cannot do that because they are not able to integrate this particular visual recognition within that optical sensor. So this is one of the enabling factor for such products and innovations. So there are opportunities in this
So you're
area.
talking about sort of subcomponents to larger systems?
Yes, yes. So it's only one of the many factors you look at.
And Greg, what's your take on that?
Yeah, just by the way, so Alistair told us that the more we argue up here, the more beers he's buying tonight, so we're going to take a shot at it. So, I mean, I think, you know, having worked at Tesla, I mean, one of the areas I used to get a lot of questions on was on autonomous driving, and I think, you know, it's an area that is just so incredibly overhyped today. There's a lot of good work happening, but it is very overhyped. And I think to the question, there's a lot of areas that are maybe more traditional where there's a lot of really neat applications. One area that's pretty important to me is, you know, prior to Tesla, I worked at SunPower when we were working on energy production, solar energy. And it's pretty obvious to me that if you think about like the long arc of society and how we really improve, energy is a really fundamental thing that we need to be working on. And I don't think it's getting enough focus, in particular from this area. So I was recently reading some things about some work that's going on with nuclear fusion right now and how you can apply machine learning to go help solve some of the problems with plasma containment. And it's pretty cool. It's like this massive, super complicated problem, very hard to model today. And you know, even just kind of the early bits of work that are happening on that today are showing like a 50% reduction in losses. So it's an area that I think it needs a lot more effort. It's maybe out of the hype phase right now, but certainly is something very important for us.
Why, I'm curious why, if you guys have any opinion, well, yeah, Mark. Yeah, I'd love to know what you're thinking about, you know, some of the areas perhaps in and around health that, you know, are underexplored.
So one of the things that I think is interesting in healthcare, where there is a lot of work happening with machine learning, but there's a meta problem I want to talk about, which is that most of healthcare is data starved. And machine learning thrives when there are appropriate and large data sets. And people are surprised when I say this, I've said this in other forums, because they think that, you know, we have EMRs, we have enormous amounts of data in healthcare, but in fact, most of the data is either trapped in silos or is unstructured. So there was a scathing editorial in the New England Journal that came out just this week about the adoption of EMR technologies because of the High-Tech Act since 2009. And basically, to paraphrase, the New England Journal said an old joke about EMRs, which is these hospital systems are scanning faxes, putting them into their EMRs and calling themselves digital. And the thing is, that's not a joke. The place that AI can play a role here is in taking all of this unstructured data and actually making it structured so that we can start to learn. I think many of the most interesting problems in healthcare will get solved when we take all these disparate data sets. So my company works on the genomics of cancer. There are folks who work on germline genomics. There are people who have phenotypic or treatment or outcome information. There's health economic information. There's all of these vast data sets. None of them work together, and many of them are unstructured. So if you could build the layer that does some of this structured to unstructured or unstructured to structured work, I think that the applications that would fit on top of that would be very powerful. And there are some companies in the Bay Area that are starting to think about this. But it's interesting how primitive some of the solutions are. So there's AI to OCR documents, and they do their best to make it structured. But then ultimately what they have is a slew of nurses sitting in a low-cost region of the world who are taking these documents and actually coding and tagging them. That seems like the kind of problem that we ought to solve, and then I think you'll see an explosion of healthcare applications on top of that.
Got it. So I'm a little curious, why do you guys feel these disparate applications are underappreciated? Who's to blame?
The investors.
Yes, double down on that.
Mark?
Well, I mean, so the type of problem I just described is one that is a structural problem, it's a regulatory problem, and it's a long and a hard problem to solve. So most investors don't want to make a bet on something where there's technical risk and there's regulatory risk, and you're building a picks and shovels business where the applications are not entirely clear that sit on top of it. So sometimes, I mean, infrastructure plays like that are difficult.
For the areas I described, I think sometimes it's just you need people with domain expertise sitting together with the people who has the knowledge of AI. If you don't have that, so many of the problems you cannot really discover the opportunities.
I'll add one more to that on top of the investors. So it is a societal human bias to some degree, meaning just going back to what Mark said a few minutes ago about data being a problem and how all machine learning applications require a lot of data. That is a self-enforcing bias, a feedback that everybody believes in, and so you develop algorithms that require that. On the other hand, if we take a step back and say, okay, nature doesn't need a whole bunch of data to compute. You have zero-shot learning, you have single-shot learning. Nature optimizes for different things. You have other examples of compute out there we can draw on. So then it becomes a question of what morphology do you want to use? Do you want to throw power at it, or do you want to come up with something smarter? So in some sense, because we're training our talent in a specific way, most computer scientists don't get exposed to philosophy, for example. Like, they don't get exposed to different mental models they can draw on, which is why some of the best data scientists come from other fields. And also because that's the talent that is being in demand, right? Deep learning experts are in demand right now. A few years ago, it was machine learning and big data. So it's a societal bias. It's not one thing or the other. It becomes a reinforcing mechanism. You don't have people who think different.
So Radhika, you're saying you disagree with everyone else on the panel.
Yes.
Excellent.
One beer.
One beer. Yeah. One beer. All right, mark her down.
So, leading off of that, and actually, Radhika, I'm actually going to bounce this back to you. The question I have is, how is AI and ML changing the ways that products are built today? But I'm curious how you see the inherent biases associated with the groups you just described really affecting that. Yeah.
So what's happened is when people are trying to build for the products today, they look at what's available or what was possible 5 years ago, and they take that and they build for a world of the past. They're not building for what AI or computing or hardware will be possible in 5 years from now. But by the time that product reaches market, it will be 5 years from now, and it will be sort of an okay product as opposed to something mind-blowing or something moonshotty, which is why with every release of the iPhone, we get lesser and lesser excited about it. Like, thinking back to how Steve Jobs used to unveil, and it's like, oh my God, this thing from science fiction, you don't get the same feeling. Oh great, this version, you don't have the home button, wow. All right, so AI is changing the way products are made, but again, it goes back to, let me collect more and more and more data. So you have a bunch of apps that just collects data, but they're not even using simple algorithms now to give you insight and feedback to really, really change your behavior. I can quote like bunch, like classic examples would be fitness apps. Like everything is tracking everything you do, but how often does it really interrupt you for the better?
So can I jump in on that? Because one of the things that I think has been unexplored in health, and you touched on it, Radhika, is there are a lot of continuous monitoring apps that exist today. Most of them are geared towards the worried well and worried wealthy. So probably half the people in this room are on Strava, and last weekend you checked your time going up to Skyline, and that's terrific, yay. But that has nothing to do with most of the health costs and health care that is provided in the States, which is, and most of the world, frankly, which is about taking care of people who have chronic disease or who are elderly. So things like COPD and diabetes absorb the vast majority of our health costs and our real problems. And there are coaching applications that can work. We know the things that help, right? Eat right, exercise, take your pills on time, don't smoke. But how people getting people to do those things is not easy, and coaches have existed for quite some time, and they have helped us human beings to change behavior. I haven't seen enough effort put into creating applications like that, which can actually bend mortality curves and change outcomes in chronic disease. I've seen an awful lot of effort, and this is probably a little bit of Silicon Valley navel-gazing, where people are making apps that are really interesting for them and their buddies who are relatively young and relatively healthy, and I think we need to see a change there.
Got it. And so, Greg, I'm curious your take, sort of looping it back around to how products are built. Like, how do you see that changing? How do you see the AI machine learning stuff affecting that?
Yeah, I have to say, by the way, when I walked in today, I was a bit taken aback at first. I walked in and I saw a bunch of people in suits and ties, and I thought, there's no way in hell this is a hardware group I'm speaking to, which it turned out it was the session next door, not this one. So, yeah, I mean, there's a lot of really cool stuff happening, and I think along the lines of what's already been discussed, maybe one little counterpoint I would take is I've seen some just huge value in collecting a lot of data and then doing some pretty interesting stuff with it after the fact. And for all of you that are building hardware products, I think one really important area where you'll see this is in the area of quality and reliability. So to give you an idea, you think of something like the Samsung event that happened with the phone catching on fire. Nobody wants that to happen to their product. There's a lot of really cool things happening right now with using really good vision, computer vision techniques, coupling it with machine learning to go do defect detection. It's been around for a long time, but typically it's been go look for this particular defect in this little area or go measure this dimension. What's really changing now is that by collecting this really, really high resolution image of the product as it's being built and then applying machine learning to it, it's able to detect things that you would never even know were wrong with the product. Then you can kind of go back and correlate that to performance. So it's pretty cool, and there's a lot of work happening there, and I think for those of you that are developing new products, you should be thinking about that. And especially as you're in the development stages of your product, it's a really great way to learn during that development phase what needs to be fixed. So that's one. The second one that's pretty cool too, I think, is in the area of just automation. I don't know if any of you have been on a tour of the Tesla factory, but it's kind of a story of two
Shameless
halves.
plug.
Yeah, no, I don't work there anymore. But it was a tale of two halves. Like the first half of the factory was all completely automated, thousands of robots, and the second half is extremely manual. The places where people are doing the finer things like installing trim or plugging in connectors. And the problem is industrial robots for a long time, as you probably well know, they're really good at going to the same spot every time and interacting with a very fixed thing. Kind of a funny side story, by the way, during the Model S launch, we had this thing happen where we were showing the robots building the car, and one of them grabbed kind of the side of the car during the demo and flipped it around and started crashing into the robots. It was like robot war going on during the launch event. Not pretty. But anyhow, there's some pretty cool stuff happening right now with applying, again, computer vision and then using machine learning techniques to train the robots to be able to control the robot in a way that is a lot more like a human and allow us to automate things that we haven't been able to automate so far in the past today. And it's doing a lot to improve the quality and cost of what we're building.
So Luke, how do you see AI changing how products are created?
Greg mentioned a lot of cool applications. I want to mention one more example. Even this is an application that previous people would never think about, even software. We have a portfolio company that does materials for ambient sensing application. They are able to, using nano-sized material, to significantly improve the performance and lower the cost. But as many of you probably know, the nanomaterials has some of the very severe restrictions. For this particular materials, they degrade with time and depending on many ambient environment and many other factors. So they actually think about, they started using the machine learning to be able to normalize the effects by different data training and applications. So that's one of the unique way for them to get over this restriction of nanomaterials. So it's a very niche application, but the product manager somehow come up with this idea because of his knowledge about AI.
Cool. So a question I have that I think is very relevant here is, obviously we're all here because we're hardware enthusiasts, but that's a bit like being a masochist. So given that, where is do you believe that AI's software is waiting for the hardware to catch up? And if so, in which areas? And Radhika, I'm sure you have some, very, very small opinions about this.
Yeah, I do. My background is in hardware, and then for the past few years, I've jumped to software. So I have very, very few opinions about this. Okay, so I mentioned earlier that deep learning, a lot of AI, the hype as well as the possibilities are possible today, the third wave of AI, if you will, because computers have caught up. The neural nets, the deep learning neural net models, for example, that have provided us with phenomenal leaps in vision processing, self-driving cars, and other areas, came from the notion of perceptrons back in the 60s, and also the algorithms that were developed later and later. As a result, over the past 25 years or more, we really haven't seen amazing algorithmic development, and it's boiled down to we'll just wait for better hardware. Well, actually, the applications are yet to catch up to what is provided by the hardware today, and in parallel, we'll wait for the data, meaning there are lots of data problems. For example, big corporates, as we learned, throw away data after 3 years. And that's just like, why would you ever do that? And that's because you realize in the world back then, data wasn't as valuable. So in some sense, we are already seeing quite a bit, but the hardware itself can be better optimized towards application-specific integrated circuits, for example. So you can dive into what machine learning algorithms actually use and how they work, and you can design hardware for it. So this is a trend that we're seeing now where we move away from, over the past few years, where we moved away from CPUs to GPUs, and then realizing, but wait, GPUs themselves are not really meant for machine learning applications, and so here comes TPUs. But then again, you can take a step back and say, all right, if we want to really develop hardware for amazing artificial intelligence applications, again, remembering moving beyond from mimicking human intelligence to beyond human intelligence, you would start thinking, designing hardware differently. How can it leverage different timescales in parallel? And I don't mean the chopping up your different processors and calling it parallel processing. So for example, we can take a page out of, again, Nature's notebook and see, how does the DNA compute, right? So the DNA is beautiful. It's this very elegant solution where storage, coding, and processing happens in the very same hardware. They are interweaved. We don't have that, even in today's amazing TPUs, whatever you want to pull up. We don't quite have that. It's in different phases. You can even boil down to the neural nets. And you can say, is the reduction of a human neuron to ones and zeros and a binary output the really right way to model it? And what would a hardware that doesn't just do that look like? And start developing for the future. So in some sense, for immediate applications, to solve for problems from the past, AI applications are not waiting for hardware to catch up. But to solve for problems of the future, AI is absolutely waiting for hardware to catch up.
Mark, would you agree?
Well, so in healthcare, we are absolutely waiting on some hardware advances. So what I mentioned earlier was chronic disease management feels like an area that is incredibly important, and a lot of that can be managed with continuous monitoring. So there's a lot of talk and hype around the notion of somebody who is diabetic, and if you are able to monitor their glucose continuously, for example, somebody who's got COPD, can you have a pulse oximeter that is measuring blood oxygen levels continuously? These pieces of hardware exist, but they're not tiny, they're not commoditized, they're not cheap, they're not sexy to wear, and they're not easy yet. I don't think we're very far away, so I don't think this is a 5, 6, 7 year out problem. But I think for many of the advances we want to see, where the machine learning will ultimately be really critical in doing things like diagnosis and crisis aversion, et cetera, you need the continuous monitoring piece, and for that you need the right hardware for it's basically a sensors problem.
Got it. And Luke, What's your take? Do you think we're waiting on the hardware, or do you think we're waiting on the software?
Well, I think it's all relative, and you can argue both ways. For hardware, for existing hardware, we are waiting for the algorithm to improve. Maybe they can train with smaller data set, or maybe they can do unsupervised learning. For the existing algorithm, we are waiting. We are waiting for better hardware. As Radhika mentioned, that even GPU is not really built for machine learning applications, and for many specific problems. For example, deep reasoning. Deep reasoning, maybe we need to improve the hardware to have better access to memory and for storing complex data sets and the models, etc.
So Greg, this panel so far has been very, very, everyone's just been way too polite. Yeah. Can you, help me with that?
Yeah, so, all right, you're all wrong. Is that good?
Yeah, that was pretty good.
All right. No, let me just take a counterpoint on that. So I think, while a lot of the ideas that are discussed, I definitely do agree with. I think there's another subtle part to it too, which is if you kind of look at a lot of the problems that are being solved right now and how effectively we're using the hardware, it's pretty awful. So if you look at, are you really CPU bound? Are you IO bound? And really, are you really effectively using the CPU power that we have today? In most models, and even on like dedicated machine learning rigs, like the actual percentage of like effective use of the theoretical processing power is pretty awfully low, even when you're spending a lot of time trying to optimize for it. So I think there's still a lot of work to go do in thinking about the software and the architecture and how we better utilize the hardware. I do think, though, that it's probably a level even above just thinking about software, and it goes to thinking about what are the kinds of algorithms that we're trying to develop and how do they actually function, and what does that imply we have to then go build for hardware and for software to go solve those things. And there's a whole, we could get into a whole rat hole around just like a whole other class of problems that are related, with lots of variables, and how do we go solve those, and is quantum computing the right thing to go after to go solve those, and it's kind of maybe a bit of the next hardware platform, but I think different algorithms are going to be a very important part of making progress.
So given that we've just mentioned quantum computing, and this is your fault, Radhika, I'm sure you have an opinion.
Yeah. Quantum computing is something I'm super passionate about. I went and did a PhD in it, and I was actually building quantum computers, and then I left. So things haven't changed very much since when I left the field in 2010, and I've kept abreast of it. Quantum computing is super exciting because it's the first truly parallel processing capability that's brought to the thing. In fact, I'm quite pissed that the traditional computing industry stole that term because it's not actually parallel processing. But having said that, quantum computers, even if you have a true honest-to-God quantum computer, which is at minimum 7 years out, maybe, and even if you have that, there are only 3 classes of problems that they are known to be able to solve very, very well. It just so happens that these 3 classes of problems, factorization, traveling salesman, and search, happen to be very important ones, but then they're not going to be able to do, for example, NLP and go into deep reason and understand human language, for example. There isn't a clear path to that. So the people who are building the quantum computers, the attitude is very much like, if we have this, things will be amazing, with no clear clarity on how exactly will it be amazing. And now in the interim, what's also happened is we have these sort of hybrid algorithms where can we take a page from quantum algorithms and embed it or encode it via AI or machine learning means. And that space to me is really, really more interesting because we're not waiting 7 years for a maybe technology. But I do think a lot more investment needs to go into quantum computing, DNA computing, all other types of computing.
Got it. So I think I've got one more question, and then we're going to start talking more about taking more of your questions, which are going to be much more interesting than ours. So some of the crazier ideas about what AI enables include brain-machine interfaces, home robots, weird things in biology that I can't even really describe because not having a PhD in biology. I'd love to ask our panelists here, starting with you, Luke, what do you think are the biggest moonshots? The craziest stuff you could possibly imagine?
So for brain-machine interface, there are very long-term moonshots, obviously. You can think of, in the future, you can use brain-to-cloud or brain-to-brain communication instead of currently very low bandwidth human language communication. So in order to achieve that, there are significant hurdles, technical hurdles, obviously. One is increase the bandwidth for brain communication. Secondly is to solve the implantation and invasiveness problem. So those are two very challenging technical problems. But even for brain-machine interface, there are midterm or even short-term applications. So for maybe within 5 years, you can see a lot of progress within the healthcare field, and where the implantation problem is not considered a hurdle because it's mostly treating brain injuries. But for even shorter term applications in adaptive learning and education, where you don't need to overcome these two technical hurdles. So that's relatively shorter term.
So Mark, what do you want to see? What are the moonshots you're praying for?
So two things. One is along those lines, actually, I want to concur, there are many exciting things happening at the brain-machine interface. I'm on the board of a company that is building a implantable retina for people with macular degeneration, and it does a couple layers of neural processing. Light comes in, it does some lateral inhibition, and the right electrical impulses come out the back, and the goal is 400 pixel by 400 pixel vision for somebody who's going blind, and that's enough to recognize a face or not bump into a wall. It's not tomorrow, but it's not 10 or 20 years away. There are some biocompatibility problems, et cetera. I think that feels very moonshotty, but I think within reach. For me, I talked about one meta problem earlier. I want to talk about one other interesting sort of problem. In healthcare today, the way clinical trials are done is completely broken. We draw an analogy. The last AI class I took, I'm going to make a confession, was 27 years ago with Barbara Gross about NLP, and it was all expert systems, and all I remember from the class was that it didn't work. And the reason, and expert systems had all sorts of really profound challenges. Well, I think of clinical trial design today, they are expert systems. You design everything up front. You have to know the protocol in advance. Nothing changes. It takes 8 or 10 years to read out. You need 17 experts. And then at the end, maybe you get the result you wanted. And it was a big deal when they went to adaptive Bayesian design. And like, wow, that's still have to know the protocol up front. What needs to happen in medicine, in my opinion, is machine learning sitting on top of all the real world data. Every physician in this country and around the world every day runs N-of-1 experiments, and people talk about the deep web. I think of this as deep med. There's like, this stuff disappears into EMRs. Cancer patients are dying. I try a therapy. You turn out to be a super responder. It's shocking. It's wonderful. You live 5 years longer than I expected. Well, why? Nobody knows. And it disappears because it wasn't part of a clinical trial. That seems criminal to me, and the kind of thing that the machine learning will help to tease out the results, but this is also sort of a structural problem we have to solve first. So,
I have a follow-up question on that, actually. I mean, what do you think is holding that back? I saw a paper out of Stanford that was on using cameras on a cell phone to basically do skin cancer detection, and it showed that, it was pretty early, but it was like the sensitivity and specificity was way better than like a panel of 10 of the leading dermatologists.
Well, so that particular app, which I think is called Mole Mapper, actually does work. And what's interesting is the very specific, I'm going to call them like obvious machine learning applications in healthcare, where you're like, we can read scans better than a radiologist. We can read moles continuously over time, far better than a dermatologist. There haven't been a lot of hurdles there. The FDA is very forward thinking on this. They're okay with black box algorithms, which to me is sort of shocking, but they're okay with that. And the regulatory environment for that has been fine. The thing is, those still have sort of a prescribed trial you run. And maybe there's vast data sets of were old patients. We took pictures of their moles over time. We know what the radiologist read. And so I can just do a comparative trial. So that's been wonderful, but I think it's a fraction of the problem. What we aren't solving is the unknown unknowns. That's a known unknown, not an unknown unknown. And I think that there's all of these insights buried in sort of EMRs that we don't even know the questions to ask, but this is the kind of thing that, you know, ML done right does a really good job with. If you could get doctors to change practice based on the results, which is, and maybe at the crux of the problem, is that physician scientists are trained to be they're expert systems. They are trained for good reason, they're trained in a very conservative manner, and this is kind of a new frontier. And I actually think it's at least as much a psychological and educational hurdle as it is, you know, underlying data.
So Mark, it sounds like you think that the biggest moonshot is actually drawing these insights from these data sets in a meaningful way to, you know, save a whole lot of lives.
Yeah, so we don't know what we don't know, I think is maybe sits underneath all of that.
Yeah. So Radhika, would you, what would be your take on that?
Yeah, so on the brain interfaces, I think that is actually a little bit scary for two reasons. One, it's a very reductionist approach. We simply do not understand enough about the brain yet. And to jump into trying to control it, trying to interface with it, et cetera, perhaps that would be a path to understanding the brain, maybe. But it doesn't seem to me from current neuroscience research that that's really even possible. And it's also shortcutting the problem that a human computes wholly, more holistically, meaning right now we already know from research that we have enough of a brain in the gut equivalent to a cat brain in terms of number of neurons. And there's also a lot of pre-processing that the human body does all over before it sends up information into the brain. So there are lots of things we are very unclear about, and we're jumping the gun to there. And of course, there's a whole host of safety issues and hacking the brain, et cetera, assuming the technology works. So I'll take the counterpoint to, I'll disagree with Elon and say, hey, if you're worried about AI, I'm actually worried more. I think that is the existential risk, is having interfaces in our brains that anybody and everybody can control. In terms of the moonshots, I'm a big believer in moonshots, and that's why we started XLabs. So the company I work for right now, we are a moonshot factory creating futures that are going to completely redefine how we think about specific ways of how things are done now. And we're focusing on 3 areas. So I'll just pick, so one, for example, is genetics. And the attitude there, for me, the moonshot would be taking health, the health industry today, and moving it away from a death prevention industry into a super wellness industry. That would be a moonshot. Specifically in terms of genetics, we would have a forward-looking map of the human genome as opposed to what we have right now, which is a backward-looking map, meaning what we call as genes are things in the nucleotide chain that correspond to a specific disease. And so there's a huge gap between understanding genotype to phenotype, for example, that AI can absolutely help because it's a computational nightmare. In terms of a specific moonshot that I'm super excited about, this would be the Diamond Age. So a young lady's illustrated primer is a science fiction reference, and it is by Neil Stephenson.
One beer.
I am working for this one. And it's basically how you would educate our future generation. And it's a cognitive enhancement device that automatically teaches you, depending on your background, your context, where you are now, and how you learn best, what you should be learning best for your future. You know, there are ways we could rig this up right now. It won't be as elegant as presented in the book, the Diamond Age book, but nevertheless, that would be a moonshot because it brings back something that we're missing every single day. We're depleting it, and that is agency, bringing back agency to our individual human intelligence.
So, okay, so Mark, you've talked about the known unknowns. Radhika, you're talking about, you know, actually educating and, you know, teaching. Will someone please talk about robots? Greg?
I was going to talk about something that was really going to make Radhika's skin crawl, but
Maybe you can do that too.
all right, let's start there, and we'll go to robots next. That's easier to talk about. Yeah, I mean, one thing that I think is kind of interesting, and it sounds kind of crazy, is the idea of AI-directed evolution. So, and not the kind of Skynet modifying our genome to make us passive sacks of meat, but more of, if you think about looking kind of at the history of disease, and, outside of my area of expertise here, so please stop me where I go wrong. I looked at like the last 100 years of progress on reducing mortality. It's like there's been some pretty huge progress in a lot of areas, but one area that has basically been dead flat is birth defects, and due to genetic causes. And it was shocking to me how big a problem this is. It's like 3 million kids die every year from birth defects or from genetic defects, which is like, to put it in more kind of human terms, it's like since we've been sitting here, 300 kids have died in the last hour, which is kind of shocking to me. And I think, to the point that we were talking about earlier, I think there's just a ton of really good work that needs to go happen in terms of better understanding the genome, understanding and mapping that to these diseases, and then, the big moonshot being like, how do we take that information and actually translate it into something that prevents these diseases from happening?
So actually happy to comment on that, because my wife happens to be a medical geneticist at Stanford whose job is to treat children with rare genetic disorders and to CRISPR edit to solve them. So
is Greg completely wrong?
No. So actually there's a couple of interesting points in there. First of all, there are a lot of terrible genetic disorders. We've all seen what's happened with maybe with NIPT, non-invasive prenatal testing, has gone from very rare to almost universal in certain when women are over a certain age very quickly. Genetic testing is getting extraordinarily cheap. I think we're at a $500 full exome sequencing at this point, and the cost curves on sequencing make Moore's law look slow. We're all going to have full genetic testing probably at birth and maybe before birth very, very soon. There are all sorts of funky ethical implications to that, but that is one path to where I think you'll see a reduction potentially in genetic disease, is prenatal. But the other thing that less ethically tricky is there are certainly people working on curing genetic disorders by knocking in or knocking out the defective genes. So there are people who are trying to knock out genes that are overexpressed that are causing problems. My wife's work happens to be on knocking in genes to express something that is underexpressed. So there's lysosomal storage disorders where you don't have the enzyme you need. And if you can make your hematopoietic system produce that enzyme, you can cure the disease. So you could theoretically go from a disease that is almost certainly terminal in a child who's very young to something where it's completely curative. Now, this hasn't actually happened yet, but basically everybody at Stanford Medicine, as best I can tell, is working on CRISPR editing something. And I think that's true largely, in all the research institutes around the world. I think we'll see some really exciting advances there soon. Cool. I wish she was here for my plug.
So I was going the lines of Radhika saying about brain-machine interface. I think in this area, maybe the progress can be faster than many expected. Yes, indeed, we know very little about the brain and the neuroscience from the science perspective, but there are still a lot of things can be done on the engineering side. You would be surprised how little has been done on the engineering side of how do you record or stimulate the neurons. And right now, you can only get maybe 100 by 100 electrode array to detect and record and stimulate the neurons. And we can quickly scale up to 1 million inputs and outputs. And that will enable us to quickly understand more about the different parts of the brain and speed up the neuroscience.
Cool. So I think, unfortunately, we didn't get to talk about robots, but I'm still hoping we're going to get some questions from the audience about robots. The ability of AI to predict the irrational and the unpredictable. Go.
I'll go. Yeah, this is what Nassim Taleb calls a black swan. Things that are unpredictable and yet sort of obvious in retrospect. Like, oh, we look back and it's like, yes, of course, like formation of Google was a black swan, yeah. So was Trump. I mean, I can't believe I just compared the two, but it happened. And now, at Selden, this is what we specialized in. We were predicting black swans. So the question we get a lot back, especially if we are trying to predict the rise and fall of societies via a computational framework for how societies work by looking at the data, the one question we got back a lot was, hey, did you predict Trump? So The official answer is no, because that wasn't a class of events we were trying to predict. But my chief developer, the guy who builds all the full stack, predicted not just Trump, but his strategy to the date. So if you look at the data, there are traces. You have to dig deep, but it's there. And human intelligence is enough if you have data and the access to data to do so. There was another company, I believe they're called Q2, that actually not just predicted Trump, but also Brexit and a few of the other events around the world. And they only use social media data. So yes, it is very possible to predict these things. That doesn't mean that everything that can be predicted will be predicted, or that everything ever to happen will happen. But yes, certain things are certainly possible to predict.
All this has happened before, all this will happen again?
Yes.
So, and this one actually I think is mostly for you, Greg. Since the 90s, the design productivity gap, software testing, validation, the time to actually getting a product out has, it's been decreasing, but certainly not as fast as I think people would hope. How fast do you see that getting? How fast do you see product cycles getting? Like, what does iteration time look like in an AI ubiquitous world?
Yeah, that's a really good question. I think, oftentimes, or not oftentimes, the speed of doing development is connected directly to, we'll call it, the speed of getting feedback cycles. And, the way products have been designed for a long time, it's pretty slow. So if you think about it, you sit down at a CAD station, you are drawing your product with primitives of, I want a cylinder here, I want a bar here, I want that kind of thing. And then you want to go test it, which is oftentimes quite slow. You can, do CAE, but it's not that fast, but then to build it and test it, it's quite slow. I think, one of the really interesting things that's been happening is changing design using some different techniques. So for example, one is taking design up one layer of abstraction. So not defining and drawing each primitive shape on your part, but defining your part at a higher level, saying, this is the function I need that part to go do. These are the constraints you need to go live within. And then let things like genetic algorithms go work on trying to solve it in very unique ways. It allows like the cycle of feedback to go from days and weeks to milliseconds, which is pretty cool. It does go back to a bit though of the challenge around hardware. So we were trying to do some of this when we were designing the suspension of Model S, and we'd make some tweaks and change a couple of variables, run it through a evolutionary algorithm to go try to new things on the design of it. But it would take like a week of computation to go get the answer back, which was just way too damn slow. But I think with new advances in hardware that we're talking about right now earlier, I think a lot of that will help cut that cycle down and allow us to do some pretty unique stuff in this area and dramatically collapse that design cycle down. And quite frankly, end up with designs that are way more optimized than they are today, because you're solving to the functional thing and not just tweaking something that people had in their mind early on.
So there's a report showing that the wave of internet actually has not really improved much of the productivity. But if you look at the AI, people would expect that because of the more automation of these roles, and there will be significant improvement in the productivity across other industries.
The insurance industry is basically about data and risk. And the more data you have, ideally, the better you are at predicting that risk. Now, with the increasing ubiquity of sensor data, combined with these models that can actually process very large data sets, it seems that insurance should be transforming. That doesn't seem to be something that's happening very much. I'm curious what your guys' outlook on the insurance industry from a hardware, software perspective due to the impact of AI would actually be.
So from my experience, it seems like insurance is limited by the business model and the status quo, meaning it's an old industry and it's not going to change very quickly. So there are lots of new things that are possible because of AI. But forgetting even like the talent, the access to talent, and access to tools and data, et cetera, like the regular problems, which is like the level 1 problems. AI, for example, with the amount of data coming in, we can now offer products that are priced much more efficiently and also can be updated much more often. But insurance is used to selling your coverage every year or every set period. So for example, if you go into like predicting earthquakes or something like a natural disaster, you write out the coverage for the entire year, and even if your models are being updated to tell you something now, you cannot act on it soon enough. So there is a market challenge that is very independent of the AI challenge. And same thing, what AI facilitates for insurance, which to me is like super exciting, is the possibility to cover new classes. So for example, political risk that we talked about, that Selden could do, not a lot of companies would write that. There are only 3 classes of political risk that companies even write. But because now we can start pointing to like little events that might disrupt companies and businesses, you can start writing for these things. And then on a personal scale, same thing. It's like your risk might depend on your environment, and you can tweak for this. And more than tweaking, you can interfere and say, hey, maybe you shouldn't be driving today, traffic is unusually heavy, right? So things like that. A lot is possible, but I think it's held back by the business models and the markets.
Mark, I'm really curious for your take on this.
So I have literally no insight into the insurance business, but it seems to me if there's vast data sets and enormous amounts of money to be made, that somebody has to be working on this problem. I mean, I know that there's an awful lot of investment going into other segments of fintech where machine learning is being applied to, say, consumer credit risk and how to write a mortgage, right, which is over $1 trillion annual business in the United States alone. So given the size of the insurance market, the plethora of data, the obvious utility of these algorithms, I would be shocked if there weren't dozens of good startups thinking about this. And it may be one of these things where what does it say about people going broke? It happens very, very slowly and then suddenly. Like the current insurance industry may not change at all until it changes suddenly. And all of a sudden, the businesses that are 100 years old and are in Hartford, Connecticut, and have a bunch of actuaries doing old school stuff are just completely eaten by companies out of Stanford. I have no insight into that, but I would be shocked if that didn't happen.
What do we think the effect of these systems with embedded artificial intelligence, hardware systems with embedded artificial intelligence, will be on product liability? Because if the system is making a decision itself, then who is actually liable? Is it the operator, or is it actually the manufacturer?
New class of insurance coverage. In every problem, there is an opportunity. Firefly reference.
2 beers. Greg?
Yeah, I mean, I think the reality is there will be quite a bit that's borne by the people that are building the product. I mean, if you look at it today, when a product harms people, right or wrong, or not right or wrong, but like you're liable. So, and I think more and more with decisions being made by the embedded device, you're going to see that happening quite a bit. I think the fun challenge is trying to figure out, the common problem that's talked about in the autonomous driving world is the trolley problem. How do you go solve the trolley problem, right? And I think a really important part of that is how do we start taking AI and actually start developing better algorithms around empathy? Empathy meaning like cognitive empathy, understanding what others think and what others are feeling. And I think the better we get at developing empathetic AI, the better those systems can make decisions that would be the decisions that we would want to make. And I think that's a really important part of making good embedded systems in the long future.
A lot of hardware companies out there are, contemplating building out a software stack because it's seen as the only way to compete. How would you see, like if you were a hardware company and you were trying to figure out a way to apply machine learning to some problem set, move a little further up the value chain, from your experience at TechCode, I'm curious what you would recommend to, a company considering doing that. What do they need to do? Do they do it internally? Do they partner? Like, where is best practice here?
Right. So at TechCoder, we work not only with startups, but also big corporations. And specifically for AI, because it's so transformative across a number of industries, many of the traditional industries, companies, they don't have the expertise within this area. And what we usually suggest them to do is a three-step process. The first step is obviously get familiar with AI and what are the capabilities and they can bring to the products. What are the opportunities? And the second step would be to prioritize with different initiatives, really attach that to the business value, the tangible impact. And the third step is to figure out, as mentioned, that what's the internal capability gap and whether to do it internally or externally. Most of the time, these companies, they usually have to hire external experts, a consulting team to come in to work together with the internal team. A very small team, but it's important to merge expertise of the internal with domain expertise and the AI expertise together to work it out. A short project like 3 months it's good enough so they can make a decision about the next step, whether they should move forward with a more elaborated project. So.
My advice would be, unless you're in the business of building wheels, do not reinvent the wheel. So if you are, if your core business isn't AI, or you don't want your core business to become AI, which I would actually recommend, it should be integrated. But if that's not the direction you're going to go, then go with vendors that are currently available and don't try to rebuild the team internally. That would be my biggest advice, because you have vendors who specialize in this and they're getting market knowledge and they are learning themselves and building for that. Your internal team, they are learning very deeply. And of course, this is from an entrepreneur's perspective, right? Like, go buy tools that we are building, guys. We're building it for you. But if you try to build an internal team, we see this happening a lot in some of the startups I advise too. Corporations engage the startups, we start buying our tools, and then a year later think, hey, why am I spending millions of dollars on you? I can just buy, or I can hire 5 data scientists and rebuild the team. So my advice would be to not do that, even though it's very tempting because it's a very short focus.
Mark, I'm really curious if you have any cautionary tales about what Radhika just mentioned.
So, any cautionary tales? I remember talking to Anthony Goldblum, who started a company called Kaggle, which probably many of you are familiar with, about this problem, like companies hiring data scientists. We need a machine learning data science solution, and the same way that 15 years ago, like I need an internet solution, or 10 years ago, like, oh God, I need a mobile strategy. I'm going to hire a bunch of people.
Don't forget the social media strategy. Right,
and the social everyone needs a social strategy. And while those things are true, generally building an internal team, unless, again, it's core to your business, doesn't work. And the reason it doesn't work, it's not just it's hard to recruit if this isn't core to who you are. You're going to recruit the wrong people or the problems will change. So it's not like there's, like, I'm a machine learning expert. Like, no, I mean, maybe, but most people, like, they have subsectors, and there are certain types and classes of problems they know how to solve very well. And the problem you need to solve today is not necessarily the problem that your business needs to solve 6 months from now. And that person, even if they're bright and they've got a PhD and whatever else, like, they're not trained up on that the way other experts are. So this is why sort of a supply chain of machine learning experts through appropriate consultancies can make sense for companies. I mean, I think it goes back to what Greg said, which is like, what's the problem you're trying to solve? And if you have a really good sense of the problem you're trying to solve and the segment you're solving it for, wow, this is core to our business and machine learning is going to underpin it for a long time and we're going to hire 20 people, great. If it required like two folks, and I think there's a lot of data that suggests that won't work very well.
So do you guys have any suggestions for small hardware business owners? Like people who are, making a little bit of money, building a part, building something well, but it's never going to be like a massive, venture business or anything. Like how should they adjust to these changing winds?
You have to know your customers. So if what you're building is really relevant today and will be irrelevant a year from now, your customers probably know that. I think it starts with talking to them.
Yeah, I think it's a blessing and a curse actually, because if you look at large manufacturers and they do all of this consumer research and they are all about building products that are irresistible. So this sort of notion towards getting us addicted to our devices, whatever the device might be or whatever the product might be, is huge. Now, when you're a smaller manufacturer and you're building you have a smaller scale operations, you perhaps don't have the budget, the resources, and the teams to go do all this massive research, which means if you focus on what is actually good for your customer, I'm a big believer in that will take off because you're doing the right things. And it might be hard, it might not be like, scaling at the rates that you have your S scale taking off, but it will be the right thing. The way you can integrate what's happening in the market right now. So my husband's actually building a small hardware, and he intentionally moved away from the venture-backed world, and he's like, no, I'm just going to build this because this is important, and we need to bring back wellness. It's a wellness device. And so you can still leverage all the learnings that you're getting online in what the trends, et cetera, and rebuild it into your product, but not necessarily spend a lot of money chasing building an addictive product.
Don't view like AI as something that you need to go do for the sake of AI or machine learning. It's like go figure out the thing that is going to make your product better and go find the right tool.
And I think on that note, we're done. Thank you very much.
Fantastic job. Thank you all.